So let's have examples of linear permutation or finding permutation of n objects taken r objects at a time. So a class is to select a president, a vice president, a secretary, and a treasurer from 7 class members. How many arrangements of class officers are possible? Pause the video and try to answer this question. Alright, so we're going to choose from 7 class members. So we're going to choose from that, so we can write this as the permutation of 7 taken. Now how many? 1, 2, 3, 4. So that's the permutation of 7 taken 4 at a time, or can be written like this, which is actually from all the 7 possible class members, we are just going to position them into 4. So we would need to remove the others by removing the 4 from the 7. So this will be 7 factorial over 7 minus 4 factorial, which will be 7 factorial over 3 factorial, which will give us a final answer of 840 possible ways to arrange the class officers. Now, another example. How many 3-letter words can be formed from the word destiny? The word may not mean anything. Pause the video and try to answer this problem. So, in this case, we want to take 3 letters from destiny, which has 1, 2, 3, 4, 5, 6, 7. 7 letters. And take note, they are distinct. On the first problem, we know they're distinct because, well, no one is a carbon copy of the other, nor a clone, and there are 4 distinct positions. Here we have 3-letter words, and we have distinct letters from our source. So with that, we can now take the permutation of 7 taken 3 at a time, which would be 7 factorial. All of those divided by 7 minus 3 factorial, which would be 7 factorial over 4 factorial, which would give us an answer of 210 3-letter words. Although they might not mean something, but we can form 210 3-letter words from the letters of the word destiny. Let's have another example. How many 3 and 4-digit numbers can be formed using the digits 2, 3, 4, 5, and 6 without repetition? How many of these will be greater than 400? And how many will be less than 400? Pause the video and try to answer the questions. Alright, let's answer the first question rather. How many 3 and 4-digit numbers can be formed? Now, since we're asked how many 3 digits and 4 digits, that means the answer to this would be, by the addition rule, the sum of the 2 cases that we're actually counting. The first case is the 3-digit numbers, while the second case will be the 4-digit numbers. So, let's look at the 3-digit numbers first. For the 3-digit numbers, I have a choice of 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5. So, out of 5, I'm just going to choose 3 digits, which is the permutation of 5 taken 3 at a time. So that would mean I would get 5 factorial over 5 minus 3 factorial, which would be giving us 60. So there are 60 3-digit numbers that we can form without repetition from these numbers here. So we'll have 60. The second case is if we have a 4-digit number. So we still have 5 given numbers. So that will be from 5, we're going to take now 4. So that means we need the permutation of 5 taken 4. So in this case, we have 5 factorial over 5 minus 4 factorial. And this will actually give us 124-digit numbers. So with that, we can now get the total number of, numbers, 3-digit and 4-digit numbers that we can form. That will be 60 plus 120. That gives us a total of 183 and 4-digit numbers that can be formed using the digits 2, 3, 4, 5, and 6. Now, how about how many of those numbers will be greater than 400? So, we have the numbers 2, 3, 4, 5, 6. If we're going to form 3-digit and 4-digit numbers, how many of them would be greater than 400? Now, we know that if they have 4 digits, most probably they're greater than 400 already because 4-digit numbers are in the thousands. So we can already include the 120 in our computation. All we need to figure out will be the 3-digit numbers greater than 400. So, if we're going to have that, the 3-digit numbers greater than 400, we can't immediately use the permutation of 5 taken 3 because they're all the 3 digits and some of them are smaller than 400. Now, it will be possible that the 3-digit number will be bigger than 400 if the first digit, or the hundreds digit rather, this one here, can either be 4, 5, or 6. Because once I place here another number, for sure it's bigger than 400, 400. So I have 3 possible options for the hundreds digit. Then I can choose any other for the tens and the units digit. So this is your hundreds, this is your tens, and units digit. Oops, I should have written here hundreds. So with that, I already have 1. So therefore, I'm going to have here 4 other choices, then 3 other choices here by the fundamental principle of counting. Therefore, this is actually 36. So the total number of 3-digit and 4-digit numbers greater than 400 would be 156. Sorry, this is the second question. The last question is actually how many of them would be less than 400. So if we're going to follow the same pattern or the same logic as what we had in the second problem, we are not going to include, though, the 120 because all of them are greater than 400. So we're going to only have the 3 digits. So there. So for the number to be less than 400, we only want these numbers. So there are only 2 possible numbers in the hundreds place. Then the rest can follow. So we still have 4 and 3. 4 in the tens, 3 in the units. So multiplying that by the fundamental principle of counting, we're going to have 24. So there are only 24 3-digit numbers, because we can have the 4-digit, less than 400. And those are examples of linear permutation.